Hi, this is Shaini from Department of Materials Science and Engineering, and I'm presenting my work on lithium intercalation and phase transformation behavior in layered materials at atomic scales. MOS2 is being researched as an electrode material to replace graphene in lithium-ion batteries. But understanding the mechanism of lithium-ion intercalation in between layers of MOS2 is very important if we want to predict the battery performance reliably. MOS2 can exhibit multiple phases, and lithiation can trigger 2H to 1D phase transformation. In this work, we want to study the ion intercalation mechanism and the resultant structural accommodation that happen in the MOS2 lattice during lithium intercalation. So we wanted to understand how lithium goes into the MOS2 lattice, and we performed sequential insertion of lithium to understand this. After the first lithium is in between two layers of MOS2, incoming lithium can either occupy the same layer or it can go to a different layer. Our energy calculations suggest that incoming lithium would actually go into the same layer as the first, and this suggests that lithium insertion in between two layers open up a channel that would facilitate more lithium to come into the same layer until all the octahedral or six-fold coordinated sites are occupied. After that, more incoming lithium ions can occupy the same layer in four-fold coordinated or tetrahedral sites, or they can occupy another layer. Our energy calculations again suggest that lithium would not supersaturate the same layer, but it would go to another layer. Combining these two results, we came to the conclusion that lithiation in MOS2 proceeds layer by layer. After this was established, our next step was to understand how lithiation induces this phase transformation. Previous studies have suggested that there is a critical concentration of lithium that triggers global phase transformation from 2H to 1D phase in MOS2 lattices. But our current studies suggest that as soon as any MOS2 layer is lithiated on both sides, it would phase transform locally from 2H to 1D phase. The hybrid phase volumetric expansion is actually much closer to the experimental values, which give further confidence that our proposed theory that hybrid phase is forming is true. In conclusion, we performed atomic level studies that suggest that lithium intercalation prefers to proceed layer by layer in thin films of MOS2. And this would lead to local phase transformation of MOS2 from 2H to 1D phase. Our volumetric expansion studies also suggest that hybrid phase formation is probably what is seen in experimentally. So with this, I would like to conclude my talk with a note to the publication that has most of the details for this work, along with additional calculations on charge redistribution and diffusion barrier calculations for this work. With this, I would like to acknowledge our funding agencies. Thank you all.